Here we're looking at the image that we use to set up the area between curves, and we only set this up in the interval over which f is larger than g. But what if we were to take b and move it? And then I'm going to go ahead and finish off the bottom of f here and just give it something down there. Okay. So now the edge of our region extends to where g is bigger than f. Well, I'm now going to label on the x-axis their point of intersection with an x-coordinate of c. And now we've got that the area is going to be equal to the integral from a to c of f of x minus g of x, because on that interval, f is the bigger of the two functions. But on the interval from c to b, g is the larger of the two functions. So our integrand is going to be g of x minus f of x dx. We set these up so it's always big minus small, therefore forcing our integrands to be positive. And another way to write that is to use an absolute value. So in general, the area between f and g over an interval from a to b for x is the integral from a to b of the absolute value of f of x minus g of x dx. Now you don't have to go through and you write it down as an absolute value necessarily, particularly if you have, say, a graph in front of you and you can see clearly which function is larger over a particular interval, and then you set up the integrals in such a way that that function, whichever one's larger, comes first. With that in mind, I'd like for you to do this problem. Sketch the region enclosed by the given curves and find its area. The curves are y equals the cosine of x, y equals 1 minus the cosine of x, and we're only going for x between 0 and pi. Come back when you're done. Here's a chance to check that you're on the right track or that the work you did is correct. I have here the graph of y equals the cosine of x from 0 to pi, and then y equals 1 minus the cosine of x from 0 to pi. I can see that the x-coordinate of the intersection point is x equals pi over 3. And from 0 to pi over 3, the cosine of x is the larger of the two. So for my integral, from 0 to pi over 3, we've got cosine of x minus 1 minus the cosine of x. Then from pi over 3 to pi, y equals 1 minus the cosine of x is larger. So I have my integrand for that interval from pi over 3 to pi is 1 minus cosine of x minus cosine of x dx. If you were on the right track, then just keep watching. And if not, go ahead and pause it, finish it. I'll wait a beat so you can do that. All right, our integrating gives us 2 times the sine of x minus x for 0 to pi over 3, and x minus 2 times the sine of x from pi over 3 to pi. Evaluating at pi over 3 is going to give me square root of 3 minus pi over 3. Evaluating at 0 gives me 0 for both the sine function and x itself. Evaluating at pi gives me 0 for the sine function, and so x gets replaced by pi. And then for pi over 3, we get pi over 3 minus the square root of 3. Ultimately, the answer for the area is a equals 2 times the square root of 3 plus pi over 3.